Here we go. We have a question count substrings that satisfy K constraint part 2. You have given a binary string S and an integer K. You are also given a 2D integer array queries where query I is the range of L to R. A binary string satisfy the K constraint if either of the following constraints conditions hold. The number of zeros in the string is at most k, and the number of ones in the string is at most k. So we have a valid substring if the count of zeros is less than or equal to k, or our number of ones is less than equal to k, and our substring is not valid when our count of zeros is greater than k and our count of ones is greater than k. We have to return an array answer where answer I is the number of substrings of of S from range L to R that satisfy K constraint. Suppose we have a query from 0 to 6, so we have this substring. In this substring is valid because the count of zeros is less than is count of zeros is 3 and count of ones is 2. So count of zeros uh, is greater than k, but our count of ones is less than or equal to k. So we have an invalid substring only when count of ones is greater than k and count of zeros is also greater than k. Here our count of ones is less than or equal to k. So this substring is valid. So in this length, our length is 5. So in this uh, our total substrings present is n multiply n plus 1 by 2. So 5 multiply 6 by 2 is 15. So 15 substrings present in this, and 16 is this, 17, 18, 19, 20, then 20, then 21, 22, 23, 24, 25, then 26. So our answer is 26. We have only one query, 0 to 6. 0 to 6. So if we have this input, our answer is this. So we cannot apply brute force because our constraint is the string length can be 10 raised to power 5. So we have to optimize it somehow. So let's build the approach. So somehow we have to find what is the valid substring length. So here this substring is valid, and if I take this substring is valid, and this substring is also valid. So somehow I have to find my left side or right side. So let me find both of them. First let me find my left side. So j points here and I also points here. This substring is valid. Our count of ones and count of zeros is less than or equal to k. So for this j, our leftmost side or index is 0. If our j points here, then our leftmost side or leftmost pointer is at 0. For this is also valid, so we are at 0. For this is also valid, we have 0. For this substring is also valid, we have 0. This substring is not valid, so I have to increment my I. Now our count of ones and count of zeros is less than or equal to k, or not greater than k. So this substring is valid, and for this j, our leftmost index is 1. For this, our leftmost index is 1. Let me find right side. We have 0, 1 and 1. So j points here, I points here. So for this, our right hand side is this only 6. If I have this substring, so for this, our right hand side is 6. This substring is valid. For this substring is valid. For this substring the rightmost side is 6, and for this the rightmost side is 6. For this the rightmost side is 6, and for this the rightmost side is 4. The rightmost side is 4. We will decrement our j. This substring is also not valid, so again we will decrement our j. Our rightmost side is j. Now we know left and right side, and we have a query, suppose 0 to 6. Suppose 0 to 6. So for this, we have this index, our lower bound. For this index, our rightmost valid index is 4. Rightmost valid index is 4. So we have a valid substring till 4. 0 to 4, this is a valid substring. And from right hand side, we have 6, and from 6, our leftmost valid index is 1. Leftmost valid index is 1. So we have 0 to 6 valid, and 0 to 4 valid, and 1 to 6 is valid. Its length is 5. So our total substrings in this is 5 multiplied 6 by 2, which is 15. And our 1 to 6, its length is 6, and we have total substrings as 15. I think I did a mistake. Yes, 7. Here it is 7. So n multiply n plus 1 by 2. So it is 21. 21. But as you can see, we have a range 0 to 4, and we have a range 1 to 6. This is a overlapping problem. 1 to 4. So we know its index is 1 to 4. Here we have 1, and here we have 4. We know the length 1 to 4. We have 0 to 4, and we are also including 1 to 6. So I have to, I am taking 1 to 4 two times. So one time I have to decrement. So 1 to 4, its length is 1 to 4 length is 4. So for n plus 1 by 2, it is 15. It is 10. So we have 1 to 0 to 4, our substring is 15. Then from 1 to 6, we have substrings as 21 minus the overlapping problem. The overlapping is 10. So it is 36 minus 10, 26. We have 26. In this case, it is valid. We have a valid answer. But let's suppose we have a bigger test case. So our k is 1 in this case. So if our k is 1, for this substring is valid, and let me take for this 0. For this 0, our substring is valid till here. Our substring is valid till here. So it will tell me my left side, and from here we have a right side. So if you calculate left and right, we have a gap in between. So somehow I have to also include this gap in my answer. This is not overlapping. Here we have a gap. So I have to include this. So for this we have prefix array, prefix sum. So for this index, we have this from 0 to 0 range. How many substrings are there? There is only one. If I have this range, how many substrings are there? That and on jth index. there are only two substrings, 1 and 2. These two ends on jth index. So here I have value 2, but this is prefix array. I will include my previous answer. So here it is 3. We have this range. So for this range, our length is 3 and valid substrings present in this is also 3, because this is a valid range, and the substring present in a valid range that ends on jth index means I have to include ending index. So it is equal to the range. Here we have 3. So for this the answer is 3, but I will include my previous element. This is also valid range. For this, what will I do? We have answer as 4, but I will include my previous element. The answer is 10. This is a valid range. For this, our answer is 5, so I will include my previous element. It is 15. For this, it is not a valid range, and its initial value is 1. Its left hand side is 1. So we have a value, a range from 1 to j, from I to j. Its length is 5, and so the answer is 5 in this case, but I will include my previous element. This range is valid. We have a range from I to j, I to 6. So this range is valid. Its length is 6, but I will include my previous element. Why I am doing this? I will tell you. So now we have a query from 0 to 6. We have a query from 0 to 6. Let's take let's take 0 to 6 first. For this query, our valid answer is 0 to 4. Our valid answer is 0 to 4. How I know? Because its rightmost side is 1. Till we have our rightmost side is 1, and we have 0 to 4. Here our length is 5. So here total substring is 15. So I have to include the remaining elements. So I have to include my remaining elements that include these two also. I have to include the remaining range. I have to include the remaining range that includes these two values substrings also. So till here we have 26 substrings. Till here we have 26 substrings, and we want to calculate from this to this. So we have a valid range from 0 to 4. 0 to 4 I have calculated, and this is a middle point. So this is my middle point. So its value is 15. Till here we have 15 values, and we want to calculate from I, from 0 to j. J is 6, so we want to calculate till here. Till here we have 26 substrings that are valid, and here we have 15 substrings. So I only need these many substrings from 5 to 6 that ends on 5 and 6. So it includes all the substrings. It includes the substring till 4. So what will I do? I will subtract this value to this value. So 26 minus 15 is 11. So this is my remaining substring, uh, remaining range substrings. And 0 to 4, 0 to 4 I have calculated with my length. Its length is 15, its substrings are 15, and on the right hand side we have 11. So we have total substrings as 26. Let me take another query 2 to 5. So I have to calculate all the queries. So we have a range from 2 to 5. From 2 to 5. So uh, from 2, its right hand side is 6, but I don't need till 6. I only need till 5. So I will take minimum value. Let's suppose this is L and this is R. I will take minimum value from R and this value. So the value present on a right array on the lth index, on the lth index. So it will tell me the rightmost valid index. So we have a range from 0 to 5 and I have to calculate all the values. So its length is valid. We have a valid length from 0 to 5. So its length is 4. So 4 cross 5 by 2, which is 10. I have 10 substrings here. So as my middle point is this, which is 20, and our right pointer is also 20. So 20 minus 20 is 0. I don't need to add anything. Our answer is 20 in this case. So let me take another test case. So our test case is this. So I highly recommend you to calculate left array, right array, and prefix array for this test case. So grab your pen and copy. So it is our left array, right array, and prefix array. And our first query is 1 to 4. So between 1 to 4, I have to calculate all the valid substrings. So from 1 till 3, from 1 till 3, the substring is valid. So this is our middle pointer. Actually, before that, 1 to 3, its length is 3. So we have a total substrings as 6, I suppose. So we have a middle pointer here. Till here we have 9 substrings and we want to calculate till 4. Till 4 we have 12 substrings. So I have to take some values. So 12 minus 9, it is 3. So we have a valid length. This is a valid substring till our middle pointer, and from middle to R, these many substrings are there. So the answer is 9. So let's take another query from 0 to 5. How many substrings are there? From 0 to 2, the answer from 0 to 2, the substring is valid. So its length is 3. The total substrings present in this is 6. So till here we have 6 substrings and till here we have 15 substrings. So from our middle plus 1 to R, I have to calculate the total substrings that ends on uh, our jth pointer. So from 15 minus 6, it is 9. So 6 plus 9, the answer is 15. Let's take another query. From 2 to 3. So from 2 to 4. Our substring is valid, but I don't need till 4. I need till 3 only. So I take minimum from this value and from this value. So our minimum is 3. In this, the length is 2. So the total substring present in this is 3. The answer is 3 in this case. So let's code this. First we have n, this is string length, and m, which is query length, and left array, right array. So first I have to find the valid endpoints. So ij initially pointing to 0, and I am incrementing my j. I have to fill value on jth index. So if our current value jth value is 0, increment 0, else increment 1. If we have a invalid substring invalid condition, then I have to increment my I till we have a valid substring. So after having a valid substring, I have to fill the index. Index is I, and I have to fill on jth index. So it represents the leftmost valid index. Same goes for rightmost valid index. Both pointer points to the last index, and we have number of zeros to 0 and number of ones as 0. If value is 0, increment your 0, else increment your 1. So here I am decrementing my I pointer. I pointer is changing, and j pointer represents the rightmost valid index. So if we have an invalid substring, so I have to uh, point j on a valid substring ending point. So after having a valid substring index, we have to fill this. Next thing is query processing. This is a prefix sum on zeroth. If I only have one character, so till now I only have one substring. After that, I have to iterate, and I have to take previous value and this value. Means I pointer points to the current index, and left pointer points to the leftmost valid index. So as I discussed here, actually I erased it. So I pointer points to the current index, and the left pointer points to the leftmost valid index. So we have a range, and we have to include +1 because this is a range, and I have to include both the values. That's why I have to add +1, and I have to return a answer, a long array in a long data type of m size. M is the query size. So return, and we have a for loop. This is starting index, and this is the ending index. I have to find my middle index. So this is the middle index. I have to take minimum from ending index or the rightmost starting value. After taking the values, we have a length. So from middle to start, this is the length, and valid substrings till k is this n multiply n plus 1 by 2. This is total substrings till middle. So I have to calculate middle plus 1 till end also. So that's where prefix comes in. Remaining substrings from k or middle till end. So we have a temporary variable. From ending index, I have to subtract my middle value, and fill substring and temp. So that's it. Let's submit this. And we have successfully solved this question. If you have any doubt, feel free to ask in the comment section, and make sure to click on the subscribe button for the algorithm. And thank you all for watching.